morning, viewers. Welcome to MouShauk. Today, I will discuss some ICSE Specimen question answers on pressure in fluids and atmospheric pressure chapter. It is a chapter of class 9 syllabus. So this much part of this chapter is left, and next I will start with the chemistry chapter. Okay. So before I start, I will request you to please to subscribe my channel if you have not subscribed yet. And if you are a new viewer to my channel and if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before you start your day. So for meditation, let us concentrate for just 1 minute on a point of light. Okay. And think that light is falling at you. Your whole body is being lighted up. You're feeling energetic and happy and feeling that God is with you and helping you in your every activities of the day. And you are feeling that you are becoming successful in whatever you are doing. And for basically you're putting the effort in a situation. This is a control for doing the things. Okay. Start the day. I think it's question answers. Okay. So today we'll start with nose bleeding. These are some multiple choice questions. So nose bleeding may occur at high altitude. We know that when we go at high altitude, there's some people they have nose bleeding. Why? Because what happens when we go at high altitude, the atmospheric pressure decreases. Okay. And the inside blood pressure which we have in our body, that becomes more in comparison to the pressure of the outside. And so what happens that blood will come out as that pressure is more than the atmospheric pressure outside. So that blood comes out through the openings. So openings of the nose, nose bleeding occurs. So the answer will be the atmospheric pressure decreases. Okay. Then at a place, the correct barometric height is 75 centimeter of H. So what will be the corresponding height if water is used in the barometer? If water was used in the barometer, the corresponding height will be what? 10.2 meters. Why it is so? Because what happens? Mercury is denser. We know mercury is denser than water. Okay. By how much? How many times? It's 13.6 times dense. Okay. So if we want to use water instead of mercury in the barometer as the barometer liquid, it will be 13.6 times greater than that of the mercury. That is, if it is 75, then that will be multiplied into 13.6. Okay. Then that will be what? 1020 centimeters for the pressure equivalent to 75 centimeters of mercury. Okay. So that will be the reason. That is the reason for the mercury being the water. If we use that, then that reading will give you 10.2 meters. Okay. Now, the unit of torr is related to the barometric height as 1 torr is equal to 1 centimeter of H. Okay, the answer will be 1 torr is equal to 1 centimeter of H. Now, the atmospheric pressure at Earth's surface is P1. Say it's P1. And that of mine is P2. Okay, that means mine means below the Earth's surface. Below the Earth's surface, that means what? Pressure will be more. Okay. When we go above the Earth's surface, at higher altitudes, the pressure decreases. But as we go down the Earth's surface, the pressure increases. Okay, so that means what? When the atmospheric pressure of the Earth's surface is P1 and inside the mine it's P2, that means what? The relation between these P1 and P2 will be P1 will be less than P2. That means P1 is more than P2 is more than P1. Okay, P2 pressure of the mine, that will be more, atmospheric pressure of P2 will be more than that of the Earth surface, that the atmospheric pressure of the Earth. Okay, so the answer will be P1 is less than P2. C will be the answer. Okay, next, if the barometer is taken into a mine, the barometric height will be what? Decreases, increases, remains same, or unpredictable. So from the previous question, we know that the inside the mine, the pressure is more. So the barometric height will read more. That means the barometric height will be more. Pressure will be more. Okay. So the answer will be B. It will be the barometric height will increase. Okay. The device which directly indicates the altitude in meters instead of atmospheric pressure, it is what? It is altimeter. Okay. It does not give the atmospheric pressure, but it indicates the altitude of the, the height of the atmosphere, the height where the atmosphere is present. Okay. So the altitude in meters is denoted by altimeter. Okay. The pressure at certain depth in the river water is P1. In the river water, inside the river water, it's P1, pressure. And the same depth in the sea water, it's P2. Depth is, height is same, but one is in the river water, another is in the sea water. Then what happens? We know that sea water is denser than river water. Sea water is denser than river water. So the pressure will be what? Okay. Sea water is more dense. Okay. Salty, and so it's more dense. So at the same depth, river water will have the less pressure. River water will have less pressure. Okay. So the answer will be P2 will be more than P1. Okay. P2 is seawater pressure and P1 is river water pressure. So P2 will be more than P1, or you can say P1 is less than P2. C will be the answer. Distinguish between the following: mercury barometer and aneroid barometer, manometer and barometer. Okay. So first is the aneroid barometer measures what? The atmospheric pressure. Okay. The aneroid barometer measures the atmospheric pressure using the expansion of the metal, whereas mercury barometer measures the atmospheric pressure by adjusting the height of the mercury inside the tube. Aneroid barometer, the metal expands. Inside that, a metal will expand, and that will denote the altitude of the, the altitude. It will denote the altitude, and through the altitude, we can say whether it will have more pressure or not. Okay, what is the atmospheric pressure at that height? And barometer indicates the height of the mercury level inside the tube. Okay, in aneroid barometer, the aneroid barometer is a solid device which is easy to be transported and take readings, where this mercury barometer is very hard to transport. Okay, because there's a glass tube which can break. Okay, then the mercury barometer can be constructed easily, but the aneroid barometer requires a machinery. So construction is difficult for aneroid barometer than the mercury barometer. Even the mercury barometer is very large and fragile apparatus, whereas aneroid barometer is a compact and stable apparatus. Okay, and it is mercury barometer is very large. Okay, because there's a column has to be there, a test tube, a tube has to be there in which the mercury will be filled up like that. So it can break also. So that possibility is there. But in around barometer, that is a compact thing and stable. Okay. Now, difference between manometer and barometer. Barometer, we know that it measures the atmospheric pressure. But manometer measures the fluid pressure. Okay. And just a second. So barometer, we know that barometer, mercury barometer, we are telling you. So that barometer measures what? The atmospheric pressure, but manometer that measures the fluid pressure. Okay. And these both meant are used for weather forecasting and other applications also. Okay. But main difference is that one is used for measuring atmospheric pressure, another is used for measuring the fluid pressure. Okay? So this is the main difference between manometer and barometer. Okay. Next question is, a hammer exerts a force of 1.5 Newton on each of the two nails A and B. Okay, two nails are there, A and B, on which the hammer exerts a force, 1.5 Newton on both. The area of cross-section of the tips of A is 2 millimeters square and B is 6 millimeters. So difference is between their cross-sectional area. But force is same on both of them. So calculate the pressure on each nail in Pascal. So what will be the answer? We know that force is equal to, rather pressure is equal to force by area. That we know. Okay. But here force is given what? 1.5 Newton. Area, cross-sectional area for the first one, that is A, that is 2 millimeters square, or you can say 2 into 10 to the power minus 6 meters square. As force is in Newton, so we are converting millimeters square into meters square. Okay. So pressure will be what? Pressure will be 1.5 force by area. So 1.5 divided by 2 into 10 to the power minus 6. So that will give us 7.5 into 10 to the power minus 5 pascals. For the second one, B1, B nail, if the area of cross section is 6 millimeters square, again we are converting into 6 meters square, that is 6 into 10 to the power minus 6 meters square. Okay. So pressure will be force by area, that is 1.5 divided by 6 into 10 to the power minus 6 meters square. Okay. Yes. And that will be giving, that will result into 2.5 into 10 to the power minus 5 pascals. So for A, the pressure will be 7.5 into 10 to the power minus 5 pascals. And for pressure B, okay, it should be B, not A. That will be 2.5 into 10 to the power minus 5 pascals. Okay. Next. The pressure of water on the groundwater is 40,000 pascals. And on the first floor, ground floor is 40,000 pascals and the first floor is 10,000 pascals. Pressure, water pressure. Now find the height of the first floor. Okay, density is given as 1000 kg per meter cube and acceleration due to gravity, that is 10 meter per second square. Okay. So let us see. Again here, pressure is equal to what? It is rho, that is density, into gravitational force into height. So from this we can know the height of the floor. Okay. So pressure on the ground floor is 40,000 pascals and pressure of water on the first floor, that is 10,000 pascals. Okay. Now density is given as 1000 of water. It is 1000 kg per meter cube, and acceleration due to gravity, that is g, that is given as 10 meter per second square. As we know that P1 minus P2 is equal to rho GH. P1 minus pressure of water of the ground floor minus the first floor will be equal to rho GH. That means 40,000 minus 10,000 is equal to rho GH. Rho is given as 10,000, G is given 10, and height we don't know. That means H is equal to how much? H is equal to 3 meters. Clear? Next, we are moving to last question. In hydraulic machine, a force of 2 Newton is applied on the piston of area of cross-section 10 centimeters square. What force is obtained on its piston of area of cross-section 100 centimeters square? Okay, so in hydraulic machine, force is 2 Newton, which is applied in the piston of cross-sectional area is 10 centimeter square. So what is the force of area of cross-sectional area 10 if it is 100 centimeters square? Okay, so pressure again force by area. So force is given 2 Newton and cross-sectional area is 10 meters, 10 centimeters square. So that will be equal to 0.2 Newton per centimeter square. Okay, so here we know pressure is 0.2 Newton per centimeter square. Now area, if it is 100 centimeters square, then what happens to the force? Force again, here force becomes pressure by area. So pressure is given as 0.2 Newton per centimeter square and area is 100 centimeters square. So that will be how much? 20 Newton pressure. Sorry, 20 Newton force will be there. Force will be equal to 20 Newton on a cross-sectional area of 100 centimeters square. Clear now? So this is the end of this physics chapter, that is pressure in fluids and atmospheric pressure. And next video will be on chemistry. So I'm preparing it. It will take some time. So do bear with me. And in between, I will maybe I will give you some biology question also. So I'll try to make that. Okay. So till then, please do go through these videos. If you have any doubt, please do write in the comment box. Do share with your friends so that they can also be benefited from these videos. Do subscribe if you have not subscribed yet, or if you're a new viewer to my channel, so that you can get a notification as soon as the new video is uploaded. And please do meditate before you start your day. Okay, and maintain a chart of your subject, what you will be doing the whole day, and at the end of the day, check how much you have completed, and that will help keep you on track. Okay, help you to keep on track. So thank you for joining, and have a good day.